Spherometer. A spherometer is a precision instrument to measure the radius of curvature of the spherical surface. The spherometer consists of a micrometer screw threaded into a small tripod with a vertical scale fastened to it. The head of the screw has a graduated disc of 100 divisions used to measure fractional turns of the screw. Let's find the principle used in the spherometer. The thickness T of the glass strip can be determined using the equation T is equal to N into pitch plus X into least count, where N is the number of complete rotations made by the disc taking initial reading of circular scale as reference point, pitch is the distance moved by the number of rotations, X is the number of additional circular scale divisions as in excess of complete rotations. LC is the least count of the spherometer. The radius of curvature of the given spherical surface using the relation R is equal to L squared divided by 6h plus h divided by 2, where L is the distance between any of the two legs, h is the perpendicular distance between the legs and screw of the spherometer when it is above the spherical surface. Materials required: spherometer, spherical surface, plain glass slab, glass strip, a sheet of paper, a ruler. Procedure: arrange the apparatus on the table. To find the least count of the spherometer, the pitch of the screw needs to be calculated initially using the relation P is equal to the distance moved divided by the number of rotations. If there are n divisions in the circular scale, then the least count of the screw LC is equal to P divided by n, which is equal to 1 by 100, that equals 0.01 millimeter. To find the distance between the legs of the spherometer, get the pricks of the three legs A, B and C on a white piece of paper. The mean distance of AB, BC and AC will give the distance between the legs L. Raise the screw sufficiently upwards and place the spherometer on the spherical surface, which is placed on a plain glass slab so that its three legs rest on it. Gently turn the screw downwards till the screw tip just touches the spherical surface. Use a paper strip for the confirmation. Note the reading of the circular disc which is in line with the vertical scale. Let's take A as the reference variable. Remove the spherical surface and place the spherometer directly over the glass slab. Turn the screw downwards and count the number of complete rotations made by the disc till the tip of the screw just touches the plane surface of the glass slab. Use a paper strip for the confirmation. Note the reading of the circular scale which is finally in line with the vertical scale. Let it be B. Find the number of circular disc divisions in the last incomplete rotation. Now find the total reading H using the relation H is equal to N into pitch plus X into least count. Calculate the radius of curvature of the given spherical surface using the relation R is equal to L squared divided by 6h plus h divided by 2. Similarly, the thickness of the glass plate can be measured by placing the glass plate below the screw of the spherometer while the legs should rest on the glass slab. Calculate the thickness using the equation T is equal to N into pitch plus X into least count. Applications: the spherometer is primarily used by opticians to measure the curvature of the surface of a lens for the calculation of its refractive index. It can also be used to measure the depth of an etched design below the protected surface of a flat metal plate.